Welcome to D Technology. As an ANSYS channel partner, we provide simulation capabilities in the areas of fluid dynamics, structural mechanics, electromagnetics, and systems and multiphysics. D seldom supports ANSYS software in the central United States. We also provide consulting and training for the entire ANSYS software suite. Our mission is to help clients maximize their utilization of ANSYS software to the highest degree possible.
My name is Ben Banerjee, and I will be presenting to you how to do durability and fatigue analysis using ANSYS DesignLife. This is part 2 of the presentation where I will be showcasing to you how to do vibration fatigue analysis using ANSYS DesignLife. In this workflow, as you can see, I've got a mode superposition harmonic analysis that I'm trying to do. So I've got the solution from the model fed into the setup cell of the harmonic branch. The idea is that we take the results from the harmonic analysis corresponding to a unit harmonic load case to generate the frequency response function file, and then we scale the results from that FRF file for the unit load case with our spectral density spectrum load in DesignLife to do the vibration fatigue analysis. Let's open up the model within mechanical. In the system, you can see that we've got a marine alternator bracket, and in this example, we only modeled the bracket. So we brought in the geometry of the bracket, but we included the alternator as a point mass. So we are using our rigid behavior for the point mass, and as for the bracket, we've defined a material from the nCode library, from the ANSYS DesignLife material library for the AISI 4340 low alloy steel. We've also defined a name selection object on this fillet region of the bracket where you can expect some fatigue failure to happen. And I'll show you a technique where in DesignLife you can run the calculation just on those chosen nodes on the fillet. As for the boundary condition for the model setup, we've got a fixed support applied to those 4 boss faces, and we're extracting frequencies in the range of 0 to 1500 Hertz. A quick look through the results for the model, and we can animate those mode shapes. So the first mode is primarily a Z-direction mode. As you can see, it's pulling side to side. Then you can also investigate some of these other higher frequency modes just by simply animating those mode shapes. As for the harmonic run, I've applied a unit acceleration load. So this corresponds to 1G acceleration load. And on my analysis settings, I'm using a clustering option for the mode superposition run, and I'm damping out. I'm using a Rayleigh proportional damping. I'm using a beta damping to damp out that first mode response, and then I can quickly review the result for the frequency response by probing on that location, and I'm switching over to the z-axis since that's the direction we applied the unit acceleration load, and it's the same direction that we will apply the PSG spectrum when we do the vibration fatigue analysis. So it shows a nice distribution of the frequency response, and we're looking at peak amplification corresponding to 1G acceleration, corresponding to the first mode acceleration, close to 125 Hertz. In the next step, I'm going to show you how to do the vibration fatigue using DesignLife. So back into the project page, I drag the nCode SN vibration and drop it onto the solution cell of the model. This will share the solution from the model into the solution cell of the vibration fatigue glyph. Then I also drag the solution from the harmonic and drag it over to the SN nCode vibration. And always make sure that you update the results from both the modal branch as well as the harmonic branch to make sure that the results are up to date, and we can bring the result files from both of this analysis into DesignLife. Once the model is updated, I'm going to click on the solution cell. That should then launch ANSYS nCode SN vibration. Once within DesignLife, a quick walkthrough of the basic setup in the vibration analysis that we're going to do. So you can see in the FE input glyph, we've got the results from both the modal and the harmonic run that has come over. And importantly, I want to bring over the name selection, so I can actually plot that for you here. So if I go to the user option under group type, I can bring that hotspot fillet, which is those chosen nodes on which I want to run the fatigue calculations on. Under the vibration generator glyph, you have to define the power spectral density spectrum. So this is defined in units of G square per hertz. And if you remember, we applied a 1G acceleration load. So our FRF results from the harmonic run would be scaled with this PSD load to generate the PSD stress history. Now I'm coming over to the vibration analysis glyph, and then I right click and go to material mapping, and I should be able to review the material property that came over from ANSYS Workbench, and you can see that the AISI material did come over, so I just hit OK. I right click one more time and then go to load mapping just to confirm that the time history, in this case rather the power spectral density spectrum from the vibration generator channel is applied and paired with the result, and it is, and we just hit OK. And right click and go to properties, and a quick review shows the setup for the vibration load. So we've got an exposure duration for the vibration load as 1, and 1 implying exposure duration in seconds. So when we look at the result from the fatigue analysis, it should show the life in seconds. If you have 1,000, then that would be in terms of 1,000 seconds block, or 3,600 seconds would be equivalent to an hour in that case. And there's different cycle counting methods, including Doric, Lalande, narrowband, PSD, and each of these is used to estimate the probability density function of rainfall range for this PSD stress. So we'll just hit OK and take the defaults, and at this point we should be able to just go ahead and run the flow. So I'm just going to hit the run button. Now that the model is solved, let's take a look at the results. So if I move over to the fatigue results display glyph, and as I expand that, I'm looking at the life. And since we calculated the results on that hotspot fillet, it's showing a life over 339 seconds. And we can also look through the data values display glyph here on the bottom, and that also shows about 339 seconds life. And another thing that's interesting to note is the return period to exceed UTS. Usually a small number like 1 second, 2 seconds, or a few seconds to a few minutes would correspond to some sort of a static failure. But if you get over a couple of hours, as we're seeing here, it corresponds to a fatigue damage. This concludes the second part of the presentation, where I demonstrated how to do vibration fatigue analysis using ANSYS DesignLife. Thank you for watching.